So I'm Matthew Leach. I'm within MECS. I'm the lead for modelling activities, and I work with the MECS programme through Gamos. I'm also part-time. I'm an academic at the University of Surrey, and I've been working on sort of techno-economic and environmental analysis of sustainable energy for more years than I care to remember. Nigel, do you want to give a few words about yourself?
Thanks, Matt. Yeah, so I'm Nigel Scott. I'm one of the directors at Gamos, based in Reading in the UK. And I was involved with the early research into the idea of the clean cooking, which led up to the MECS program. So I've been working with Matt for many years, sort of leading up to the start of the MECS program. So my role is really just sort of supporting various bits of the program wherever possible, filling in sort of some of the data gaps and so on.
Excellent. Okay, so this is the session we're talking about today. In terms of I hope you can see my screen that I'm sharing. The aims for the session, if I can just work out how to advance the slides. The aims for the session are, I think, at least three. One of them is to give a very brief sort of showcase and guide to recent and ongoing modelling work in MECS. But we'll do that really, really fast, largely giving kind of links to places you can find more information. In particular, we want to move on and consider sort of useful future directions for MECS analysis. So getting people in the audience's views about where we should go next for modelling and analysis, and also in particular to discuss how better for those of us who kind of create results from this sort of work, how to be more effective in how we channel it so it gets to end users, whether in companies for decisions they might make or into policy and strategy formulation. So the way we plan the session is, so Nigel and I will facilitate. We will take a few minutes at the beginning to kind of outline MECS's research and to just delve in a little bit more deeply, but still at a fairly shallow level, into a couple of example areas. And then we want to give most of the time of the session to an invited panel. We're going to invite the views of three most excellent panelists on kind of if they've got any reflections on our modelling, but also generally in thinking about kind of future directions and ways to maximise the value of one's outputs. And then we're going to open the floor for discussion. As always, with these kind of sessions, please post questions and or comments that you might have on the theme of the session into the chat function, and so we'll be watching that, and we'll pick out appropriate questions as we go through. And I think as we get into discussion in the panel session, if you really want to chip into an ongoing thread of conversation, you can also use the raise hand function just to kind of draw our attention that you want to kind of chip in at that moment. So, is there anything introductory that I've forgotten to say, Nigel or Joni? I hope there isn't, but if there is, shout now.
No, I don't think so, no.
Okay, all right,
No,
thank you very much. Thank you. So, what do we mean by modelling and analysis? I'm not going to read this all out, but there are two kind of quotes that I picked out, or definitions of quantitative analysis and of modelling, which are on the screen. I think those lead to some fuzzy boundaries with the collection of data, its qualitative analysis, maybe less quantitative scenario development. But the real focus I think that we'd like to have today is interested in the sort of use of empirical evidence. So that kind of stuff that's gathered in country, for example, on how people cook in specific places, and how we make use of the results to better understand complex issues or develop ideas. So using that cooking diary evidence, for example, and how people cook, and turning it into scenarios for costs of cooking with an EPC, and maybe looking at the impacts on those costs of business models or policy measures. So data gathering is very important, but we're talking more about what we do with it and how we turn it into knowledge that can be passed on to others. My final point on this slide is that I heard in the Tanzania country presentations earlier on in this MECS week on Tuesday, that this sort of analysis had been very influential in the particular organisation, Tatedo in Tanzania, to push really hard on developing their EPC programme. and that is now beginning to thrive. And that really gave me heart that actually perhaps some of this kind of analysis of costs had encouraged them to really move on and do something on the ground. And that, I guess, is the kind of stories, anecdotes that we'd love to hear a little bit more about, and to be guided on how we can see that happen perhaps more often. I'm going to just take a few minutes to canter through an overview of the landscape of the modelling and this kind of quantitative analysis within the MECS programme as I've been able to identify it. And there may be other bits that I miss, and if there are, please chip those in as we go through. I'm not going to read this slide out because these are 7 areas that I think I can categorise our work into, and I've got basically one slide on each of those, and I'm going to very quickly talk through each of those. But I'm not trying to tell you all about the work that goes on in each area. I'm just giving you a flavour, and each slide has got links to the relevant outputs in that area if there are things that you want to delve into more later on, and hopefully the slides will be made available so that you can do that at your leisure. So the first one, where I actually put the two together, about energy demand and load modelling, and then how that leads into power systems analysis. So cooking diaries and other forms of gathering of this empirical evidence about how people cook, their views about cooking, their preferences and so on. Lots of that goes on. And then one of the areas of modelling is how we then make use of that. And this is work, in fact, which I think Nigel on the call has done a great deal of work on, which is about statistical analysis of cooking practices, in particular leading to outputs in terms of cooking diary reports. And there are links there to the 4 country cooking diary studies for Myanmar, Zambia, Tanzania and Kenya. And that leads to lots of general understandings and specific findings about how people have cooked and all of that enormous empirical database. And one of the things we've then gone on to do is to synthesize that work, to bring those numbers together and to use that to generate pictures of how people are using electricity, and in particular the kind of power loads, the minute by minute demands for electricity that come from cooking with electricity in that particular way. So this chart is hot off the presses a few days ago, which is looking at both non-cooking and cooking electricity loads for example households. In this case, a group of households in Tanzania, 88 households, which are hypothetical households that we've constructed out of the cooking diary analysis. And we're trying to do is to sort of show, if you add on cooking loads on top of the typical non-cooking household loads, how might that impact on the overall electricity demands in that region? Why do we want to do that? Well, because our power systems analysis colleagues, in particular in Strathclyde University, and Stuart Galloway, who leads that work, is here on the call, I notice, is to be able to look at the impact on the power systems, which were previously providing just that non-cooking loads for lighting and for appliance use. And if you potentially go and add on a big slug of new electricity demand in terms of cooking loads, how will the existing electricity networks respond? Or if it's quite clear that they couldn't cope with that, what do you need to do to upgrade them to make it feasible? So they've got a couple of pieces of work out recently, a sort of power system networks report with this before and after eCook is added, and then also another piece of work which is looking at hybrid mini grids and what you need to do to upgrade those mini grids to cope with different levels of cooking. Now Nigel's going to go through a little bit more as one of our 2 examples of this networks work in just a moment. So energy demand, load modelling and power systems analysis. Another slightly separate area is around this kind of techno-economic evaluation of modern energy cooking systems. So one of the very early pieces of work, which is related to MECS, was stuff that I worked on back in the sort of around 2014, 2015, where we put together relatively simple spreadsheet models of what an eCook system looked like. And at that point, it was thinking about powering a hot plate mostly through solar PV with a battery pack and the relevant charge controllers, what it looked like and how much it cost if you cooked that way compared to cooking with charcoal or LPG. And there's a report, the eCook modelling report, which really gives an overview of the and the details of that model. What's the purpose of that? Well, one of the main things we've used it to do is to underpin a fairly big report that's came out a couple of weeks ago and is having its formal launch on Monday of next week, which is about the costing of e-cook systems. And this is work undertaken in collaboration with ESMAP, and Besnik, who is on our panel today, is one of the key authors of that alongside myself and John Leary. And so I'm not going to say very much about that piece of work because we will be launching it properly on the 23rd of November. But I'll touch in on it again as one of our examples in just a minute. And that work, which is describing different kinds of e-cook systems and looking at their costs and looking at their performance, has helped to underpin another area and lead on to work on life cycle assessment. So my fourth area of e-cook or MECS related modelling work is work that Jackie Lee leads on, which is around whole life systems analysis, in particular using life cycle assessment methodologies. So Jackie's life cycle assessment work, which captures the details of what an individual system is doing, like in this example, electricity produced to power an EPC. That's in your foreground, and you're looking at the inputs of resources and the impacts on the environment of that system, but you're also capturing the manufacture of the devices and the related background effects that affect the ecosystem. So you're doing this kind of whole system view of the inputs and the outputs associated with your cooking activity. And at the moment, Jackie's work is looking at cradle to gate. So it's looking from raw materials to produce all of this through to the manufactured product being the EPC. And she will eventually be adding in some further work, which will be looking at the end of life when you take that equipment and have to dispose of it or recycle it. And early work is coming out, early results is coming out of that work now. So Jackie has published this report on preliminary assessment of cooking devices, and pinching one of the graphics, one of the results charts out from there, you get this kind of result, which is the y-axis is showing normalized analysis, but what it really shows is the kind of relative scale of the impact between impacts on human health, on ecosystems, and on resources. And you can see that there's much more impact of these systems on human health than those other two areas. And within human health, looking at the relative impacts of cooking on an EPC using the grid, or compared to cooking with LPG, compared to charcoal, or compared to fuel wood. And you can very quickly see that there's a big or almost order of magnitude difference between cooking with grid and EPC or LPG and cooking on charcoal. But there's an awful lot more detail in Jackie's report. A fifth area of work is moving on to, I would say, more specific kind of technical and economic evaluations of specific technologies or MECS type options. And there's a series of those that MECS have supported over the last year or two. One of those is around bio-LPG, so the opportunity for using waste materials for urban wastes and residues from agriculture and so on, and turning those through different mechanisms into bottled gas, and that as a substitute for conventional petroleum LPG. And the Global LPG Partnership, as a consultancy study, did work for MECS on this and published a report quite recently, and there's a link to it there. And there's going to be, there's going to be a, I can't even see it over my screen there. There's going to be a webinar which basically does a launch of that report on the 1st of December, to which everyone is invited, and I think details of that are on the MECS website. Another area, but rather a similar kind of study, was looking at bio-CNG. So it's the opportunity of, again, taking waste and agro residues and producing compressed natural gas, bottling it, and the potential for using that for cooking. And again, there's a working paper, and MECS co-funded that work, and the working paper came out a little while ago. And then finally, I'm not going to go through all of these, but if you look at the Challenge Fund projects, which MECS have funded, a whole range of those have what I would regard as an element of modelling or quantitative analysis, whether it's looking at the eco potential in Nepal, looking at the costs of other kinds of biogas portability, or looking maybe at the influence of different financing regimes in Kenya for LPG. My final kind of category area really is what I've described as national level MECS scenarios, and two examples of work going on there. One is the global market assessment, and in 2018 the original global market assessment report was launched, and the link to it is here, and there's follow-on work, sort of second version of that being undertaken now by colleagues at Strathclyde. And you can't see the detail of this, but the sort of thing with which the global market assessment does is it looks country by country at a whole range of different characteristics of the country: electricity costs, governance, demographics, gender balance, and all sorts of different things. And it really scores the viability of different kinds of MECS and ECOOC for those different locations, and it ends up with things like this world map, where the darker areas are showing the kind of greater viability, in this case for a PV battery ECOOC system. And that work helped underpin some of the focusing of MECS onto different priority countries. A very different area of this kind of national level scenario work is what's been done by the State of Access to Modern Energy for Cooking, brought out by ESMAP, I think just last month, where within that very large State of Access report, there's a very important piece of work which looks country by country in the region and understands what the cost of transition to MECS might be under some different assumptions. So there's technical and economic analysis work gone on to calculate those scenarios and the costs for transition over a long period of time. And the link to the State of Access report is there. And my final slide on this, which is not specific studies, but it's really to kind of highlight that there are at least three other important areas which I think exist within our modelling work, but perhaps don't have standalone outputs, and perhaps we don't do enough with them. So business models for delivery, for example, in the ESMAP report and the Kenya LPG financing, but we don't have a business model report. Financing options, as I've already mentioned, it features in a number of places, and even the effects of different policy options on maybe the cost or the performance of MECS type systems. So those are all elements of modelling and important aspects, but I don't at the moment can't really identify particular outputs that are really headlining those activities. So my final slide in this kind of quick run through MECS modelling is a bit busy on words, but I suppose what I want to get across is I think we're seeing some good join up between different disciplines and different types of modelling, and I've highlighted those with some of the links on some of my slides. But I would suggest that maybe some of this MECS work starts from very particular MECS options, whether it's electric or biogas or LPG, and then look broadly at the costs, the benefits, the challenges, the policies. So maybe those results aren't quite in the right language for any one stakeholder type. It's got a bit of technology, a bit of economics, a bit of policy. Maybe it's not quite the right way to package the work to influence the policymakers. That's a question out there. Do we need to change the focus and be more visibly led maybe by stakeholder questions? And I would also comment that I think in-country programs for MECS are developing very strongly. But how do we link from the growing local empirical evidence in all of these places to kind of broader analysis and modelling that we can help transfer lessons from one place to another? So those are just the points I wanted to make about the overall framing of modelling within the MECS programme. I'm going to wrap up my bit before I hand over to Nigel, just with one very quick gallop through one example area. I already showed this in one of my earlier slides, but the ESMAP MECS study of costs of cooking, and it will be a really quick run through because we have this launch event on Monday. I would welcome everyone to come and join there, and there we've got another hour and a half spent just on this study. So what this piece of work tried to do with through 5 case studies, we were comparing the current and projected cost to the consumer of a range of different electric cooking solutions and comparing that to cooking on traditional fuels. If you want to know more ahead of Monday, there's an introductory video, there's a summary report and a very long technical report that you can access from the MECS website. Broadly, the methodology was, as I said earlier, to make use of existing empirical evidence from cooking diaries and focus groups, etc. And then to combine that with the kind of techno-economic modelling. I showed that little illustration of my modelling earlier on. And broadly what that does is it's discounted cash flow analysis, which produces levelised costs of e-cooking and of traditional fuels. So it's actually, we tend to put the numbers out as the cost of cooking per month. If you spread out all of the costs, the capital costs and the operating costs, spread it out over a period of time, and how does that then impact on households' costs of cooking per month compared to use of LPG or charcoal or wood fuel? We looked very closely at cost trends for all the key components, for batteries and PV and so on, out over a number of years, and we compared it to a range of traditional fuels, either for cooking 100% with electric or for fuel stacking and doing maybe 50% electric and 50% with the traditional fuels. We gave really close attention to a number of things, the changing costs of those key components, as well as rising costs of traditional fuels. We were really interested, we got more interested over the course of the study in the role of energy efficient appliances, in particular EPCs. We focused on-grid, mini-grids and off-grid situations. And so what this little diagram is doing is saying we looked at grid and mini-grids and at solar home off-grid. And we looked both without battery, so direct cooking on grids, even potentially direct solar cooking, and then battery supported, perhaps for a weak grid situation, or for a typical off-grid where you need to provide some storage to make that PV system work. And we also looked at different business models for how to spread the costs of things like batteries and PV panels, how to spread those out over time for the end user, whether that's pay-go or utility service models. And one chart of example results, they are complicated. I'm not going to spend much time on them, but what this shows is the 5 different case studies. So 2 on-grid in Kenya and Zambia, 2 off-grid in Myanmar and Tanzania, sorry, 2 mini-grid in Myanmar and Tanzania, and 1 off-grid in Kenya. And this was looking at this cost of cooking in dollars per month, and then comparing broadly the cost of cooking on traditional fuels. And there's always a range because different people pay different prices for their fuels. So the range for charcoal for 2020 is between, say, $22.50 and $26 a month. And then what this chart is showing is the most cost-effective e-cook option we identified in that case study. And for the example of Kenya, if you cook half your food on grid using electricity and half on LPG, you can see a clean fuel stack, which leads actually to something like half of your typical cost of cooking compared to the traditional fuel. And one of the things that came out very importantly from this study is the importance of ongoing cost changes, both for rising costs, which we expect for traditional fuels, which leads to going from 2020 up to 2025 in this direction upwards, but also falling costs heading downwards, sometimes for the electric cooking options. I'm actually wondering whether this is marked in the wrong way, because this appears to show 2025 more expensive. And I think this chart possibly has it the wrong way, because in most examples, 2020 is more expensive, and by 2025, the cost of those devices have fallen. And finally, in this report, we pay really close attention to policy recommendations that we can draw out of that modelling analysis. So I can't do justice to those here, but for example, we can demonstrate the importance of lifeline tariffs, where the cost of electricity is kept lower for particular kind of parts of the total electricity use, because actually e-cooking with an efficient device doesn't use very much electricity, and you can easily keep e-cooking within this kind of relatively low lifeline tariff area, and that really brings the cost down. The importance of supporting the private sector to bring through these business models like pay-go, helping consumers understand that actually in some situations their e-cook might be cheaper than their traditional fuel, which maybe goes against traditional thinking, and developing supply chains for culturally appropriate cooking appliances, because clearly different things work differently in different areas. I think this may be my final slide on here. What use has been made of this report? Well, it's only formally launching next week, but it's been trickling out. we can clearly point directly to the cost results, the outputs, underpinning some of the analysis in the State of Access to Modern Energy Cooking Services report by ESMAP. Some of the charts are reproduced there, and hopefully that has quite a wide international impact. We also saw input from multiple reviewers who have become, we hope, a receptive audience for the outputs. And that's, again, an international network that information can flow out to. It gives background support for the overall MECS program because it kind of reinforces that view that a transition to MECS can bring cost benefit advantages to individual consumers. But they're complex results, and I would pose that question: how best to feed different outputs into practitioners' hands and policymakers' view. So that's all I want to say. I'm going to shut up now because you've heard plenty from me about this overview of MECS modelling. We're not going to take Q&A right now. Nigel's going to give his example of the network analysis first. I would again highlight the full launch of this Cooking with Electricity report, which is coming out on Monday. But I'm going to hand over, I think, now to Nigel and ask him to give, again, a brief kind of flavour of another of the areas of MECS work before we turn to our panel and let people begin to, other than us, have their voice.
Thanks, Matt. So, like Matt said, this is just another example of the work that's been done. Going back, way back, sort of before the MECS program, we realised that getting a load of people to stick a 1 kilowatt load from some kind of cooking device onto a network would have implications, but we didn't quite know what. We also spotted that there could be opportunities for increasing the use of grids by using the excess energy that's available in off-peak periods to charge batteries, and then you could cook from those batteries, so some kind of battery supported system. So this led us to ask a bunch of electrical engineers to model these kind of effects as part of the MECS program. So a lot of work's been done, and at this point I'm just going to walk us through a couple of papers that have been provided by our colleagues at Strathclyde. I'm pleased to see they're on the group, so if there's any difficult questions answered, there'll be someone around to answer them for you. But they've taken an approach where they've modelled typical networks, so low voltage networks. So that would be typically a kind of urban, peri-urban area supplied from the national grid, and then mini grids where there's an increasing amount of interest, and especially a lot of interest in cooking on mini grids. Next slide. So this is the network that they've modelled for a low voltage network on a national grid. I was going to try and talk through the assumptions that they've made, but I think I'll skip that just for the moment. But suffice it to say that this is a typical grid, and the specifications have been drawn from a range of literature covering African and Asian grids, and also in conjunction with ESCOM engineers. They've come up with this typology. So important points are this is networks feeding about 80 households through 4 feeders. And you'll note that some of the households are different colours, and the different colours represent different categories of household which have been modelled, each with different electrical appliances, and so different load profiles. And the demands of those houses range from about 0.3 to 6 kilowatt hours a day. Skipping forward, Matt. So first of all, the team have modelled the baseline or non-cooking loads using Load ProGen software. So a load profile has been generated for each one of those 5 categories of household. They've all been then summed together in the random selection of households to provide that chart in the top right, which is the total load going through the transformer. Then we've added the cooking loads. So we've looked at 3 scenarios. So one would be a low power scenario. So for example, 300 watts for a rice cooker, then the intermediate one would be 600 watts, which could be a low powered hob, and then 1000 watts, which would be a off the shelf electric pressure cooker or possibly a resistive element hob. So different loads and the profile of the load, so the dynamic nature of the load, that's been based upon empirical work that Strathclyde have done in Rwanda, and that's the chart on the bottom right, which shows you that this shows the proportion of households in the village who are cooking throughout the day. Next slide. So this is the some of the results of the modeling, and it showed that this kind of typical network should have no problems meeting additional cooking loads, even if all the households used a high-powered device such as the electric pressure cooker. So the chart on the top right shows how the voltage drop, even at the furthest point on the network, would still be within limits. And the current would be well within the current capacity limits of the cabling. But to me here, it's this table at the bottom that is the key finding. So although the cabling is all right, what it shows is that the transformer would still be able to support everybody on that network cooking with a low power device. Okay, well, if you then people started to use a more high powered device, you can see that the proportion of households that could add that load to the network would sort of drops. But even with 1 kilowatt electric pressure cookers, you can have almost half of the people connected to that network would be able to use that cooker, and you'd have no problems with the cabling or the transformer. Okay, if you wanted to get more people to cook, then you might have to upgrade the transformer. But this indicates that when electric cooking markets do take off, the network would only start to present problems when the market has started to mature. So that's well into the majority adopter stage. So that, I think, is a really interesting set of findings in that table. But moving on to mini grids then. So this was the second half of the paper that Strathclyde have published. But this is actually a layout based on a real mini grid installed by Powergen in Africa. It's a solar PV mini grid with battery storage and an inverter working on AC. So the system that's been modeled is based on the developer's specification, which is a 6 kilowatt inverter. And it's interesting, it's the same cabling as we had in the low voltage network. So as it happens, that's a regulatory requirement in this particular country. I think the thinking being that one day when the national grid reaches this community, they can just very simply put a transformer on and use the existing distribution network. Difference being a load modeling in this example was based on a mix of only the 2 lowest energy categories of household. So in the LV network, we had 5 categories. Here we just used the 2 lowest power types of household. So what did we find with this modeling on the mini grid? So they've modeled the 24-hour profiles. That's the total load on the system is shown in that chart on the right. That's X cooking, so no cooking. That's just the baseline demand. And obviously the difference is that this system, any mini grid system at the moment, has not been designed to support cooking loads. But the modeling shows that even so, the existing generating capacity could indeed support just a small number of households using a high power electric pressure cooker at 1 kilowatt. Again, existing cabling would have no problems, even at 100% adoption. It's relatively high specification cabling. But when thinking about how to design mini grids that would meet cooking loads, we need to think about increasing the generating capacity, but the team also identified some other things to think about. So that's what I've got at the bottom. On left, you've got what happens if you start to use lithium-ion batteries, which are better at providing the high currents needed for cooking. And they also point out that different designs of other types of mini grid will all be different. So this is a PV system, hydroelectric, which 24-hour power availability would be different. Moving forward, there's another. Yeah, so far we've been looking at the technical performance of mini grids, just whether they can support it and what proportion of loads they can meet. But Shafika and the team at Strathclyde also did another bit of modelling which looked at finance, which I think is really interesting. So developers are faced with a sort of chicken and egg situation. Unit prices are high because the consumption of energy is low, but then customers can't cook with their electricity because those prices are too high. And I think Shafika's work provides some really interesting insights into this debate, and it shows here how the prices can come down if cooking loads are added to a mini grid network. So she's created a model based on a Malawian AC mini grid, again PV with battery storage. And then she's considered some optimized models that would be able to meet the higher loads once you've added cooking into it. So the three sort of hypothetical models, if you like, are the three bars in this chart. And they represent model 2 is just the existing system, but with a backup diesel. Number 3 is simply a bigger version of the PV battery system that could meet all the loads. And the number 4 is a PV battery with diesel, all optimized by the software that she's used. And she found that the costs were lowest for the optimized system with the diesel. She found that the emissions were modest, and actually the effect on the proportion of electricity generated from renewables still remained very high. So she took quite a comprehensive view. But I think what's most interesting about this chart is it shows how the cost of electricity, so that would be the cost of electricity to all consumers, can drop dramatically as households start to adopt electric cooking. So you've got that reduction of cost of electricity reduced by 70% if you can achieve 100% adoption. Thanks, Matt. So I hope this is enough to give you, I'm sure I haven't done justice to the Strathclyde team at all in this very brief presentation, but hopefully at least it gives you a flavour of what's been done and to demonstrate what can be done. So now I think we're looking for practical applications. Ideally, we'd like to work with a utility or regulator to model real networks and to answer questions posed by real network engineers. On the mini-grid side, we'd love to work with mini-grid developers to help them design higher capacity mini-grids. And already other bits of the MECS program are working with PowerGen, whose example this was, to explore the effects of adding EPCs onto mini-grids. And the modelling team have got plenty of ideas of other things that they'd like to look at. In particular, improved estimates for non-cooking and cooking loads, and that's pulling in the work that Matt's doing, and looking into further technical options for strengthening LV grids and to cope with additional cooking loads. And that also includes a whole range of demand side management possibilities. There are all sorts of options for where you'd put storage, for example, to optimize costs. So now we've got this modeling capacity, a couple of papers out there. How do we get the right people to use it and to help that transition to clean cooking that the program's all about? And I think that is what we'd like your input for in the discussion later on.
Very good. So I think that's the end, isn't it, Nigel, of your of the slides. So I'm going to get rid of the screen share. We had suggested that we would have a few minutes of questions specific to the network modelling, if anybody wanted to ask anything specific. I asked that in the chat and no one's come through with anything very specific, and we are running a little bit behind time. So unless anyone's got any burning issues about the network modelling in particular, I think perhaps should we turn to our panel and we can get general discussion and questions going through that. If you're happy with that. Okay, so I think hopefully it's clear what we want to do with the panel. We want to invite people who are at the coalface in different ways to help us understand where we should go next and how we should engage better with practitioners. We're delighted to have three excellent panelists. I'll give them a brief introduction now, and then I'm going to invite them in turn to give some responses to some particular questions that we posed to them. So in alphabetical order, because there's no other fair way to do it. First of all, Besnik Hyseni. Besnik is an energy specialist at the World Bank's Energy Sector Management Assistance Programme, ESMAP, and he leads on the Financial Innovation for Energy Access Programme. He's led on the design and delivery of several clean cooking and off-grid electrification projects, primarily in Africa, and is really quite focused at the moment on integrating electric cooking into energy projects. And he was a key part of the eco costing study that I talked about earlier. Second, we have Ansila Kweka, who's a senior research associate at the Access to Energy Institute, which is a non-profit R&D think tank supporting development of off-grid sector. She's got an impressive background in economics, statistics and mathematics, but is applying that to social science research in Tanzania. I'd like to see a social scientist try and apply themselves to statistics, mathematics and economics, but that's another question. And Ansila has been managing clean cooking projects in rural and urban Tanzania. And finally, Irene Wanjohi from Kenyan utility KPLC. Irene quite recently joined the KPLC Energy Management Department from marketing. Her role now is sales growth, liaising with domestic customers, SMEs and industry. And in particular, the role of energy efficient appliances are of great interest because they potentially allow faster adoption of electricity for cooking for Kenyan customers. And Irene previously worked in a KPLC section, which was researching and introducing domestic electric appliances to customers, which puts her in a great position for her current role in marketing. So those are our introductions. I'd like to hand the floor for a few moments, then a few minutes to Besnik. First of all, again going alphabetically. The questions that we have posed to our panel ahead of this meeting are in two groups. The first group is really about the kinds of analysis that MECS is doing. And so I kind of invite Besnik to make some comments on, reflections on anything he's heard today, but in particular on the kind of analysis that MECS is doing, and then what kinds of questions really face the sector that modelling could help shed light on, perhaps some things that we're not currently working on. So Besnik, can I invite you to unmute and maybe put your video on and give us some reflections?
Hi, Matt. Thanks so much. Hopefully you can hear me and see me. Great. Yeah, so I just want to congratulate you guys. There's been a lot of interesting research coming out of MECS that, for us, working in development organizations like the World Bank, is very, very useful. Makes our job and a lot easier in terms of having the right tools to do our work and make progress with integration of electric cooking. So yeah, it's just sort of this, it no longer seems to sort of like insurmountable mountain to climb. You can't just outrightly dismiss electric cooking in projects, the way I see it, at least now with our energy access projects. We just basically need the right tools to handhold the process a little bit and find the data that supports our full-scale operations, basically having the evidence in our arsenal for the policy dialogue. So yeah, we have some quite clear protocols. The way I see it, I mean, with we have the cooking diaries that's been evolving, and it's a very good first step in beginning that dialogue. But then the way I think of it is we'd like to sort of have a toolkit that covers several key areas, maybe like sort of 4 key research areas that can be done at the country level. That I think, if we manage to have sort of data or information on those 4 key areas, then we can, the chances of success are much higher in that particular country, at least to turn something into an operation at the investment level. And these are basically understanding, like I said, understanding preferences and behavioral aspects, which shed light on demand. Demand is typically very low, and this is a key concern for utilities. Irene could correct me on this, but I think, KPLC, for example, there has been an aggressive expansion toward access, but how many of those users, what is their average consumption? For example, I think their sort of revenue per user is probably basically from what I've seen has gone down significantly, because these are not sort of users. There may be an obligation to connect them in some way, but they're not really users that generate a lot of revenue for the utility. So how can we stimulate demand? Cooking is obviously, we talk about cooking as being a key part of this, along with other uses of power. Secondly, costing to the households, and I think we were making good progress on that with the paper that we're just launching coming Monday, next Monday. Basically comparing the cost of the households to the baseline solutions, what kind of value proposition that has. Thirdly, I think we could do more on planning and targeting, sort of understanding the different segments, understanding how large these segments are, who to actually target with different solutions. And as part of that, probably also costing on the CapEx and sort of network enhancements that Nigel touched upon. Understanding what the grid reinforcement implications are on both generation and transmission distribution. In the case of mini grids, what is the additional CapEx and OpEx for a mini grid to operate and cover most of the users to cook with electricity. So this is, I guess, beyond sort of a pilot level where, we can integrate something with the existing mini grids at the pilot level, but if we're going to do this, create sort of a new blueprint for mini grids to power cooking, then we need kind of, I think, a bit more work to do there. And lastly, on financing delivery of services and appliances, I think there's lots of creative models to explore here, and we're sort of looking into this also as part of ESMAP's new program that I'm working on, and figuring out basically how we can finance appliances, whether it's utility-driven or kind of third-party sort of asset financiers that can help with that. So I won't take more time since I know others are probably waiting their turns, but those are just some thoughts in terms of the tools that I think could make a difference.
Besnik, thank you. A lot of food for thought. I'm sure we'll generate kind of questions and discussion around some of those as we go forward. I would encourage people to go on putting their points into the chat as we go. Can we turn to Ansila? Could you share your initial thoughts with us?
Hi, can you see me?
Yes, we can.
Okay, cool. Yeah, thank you so much, Nigel and Matthew, for your presentation. Generally, my comments, I would say you're doing a great work, and everyone in the world who sees your work will really appreciate, because it's a lot of work and it needs a lot of resources and time. I'll speak generally, especially on the cooking diary modeling. I really like the way you're doing it, like comparing each fuel and I mean in terms of cost and how long it takes to cook using each fuel. And this data is really important for people to understand, because I was reading some of the reports from Tanzania, and it shows that around
And Ansila, you're breaking it.
of people are cooking using
Ansila,
and
can I just interrupt? You're breaking up a bit. I wonder whether switching off your camera might possibly help.
most of them, they have this perception that cooking with electricity is expensive, and this is because they're not aware of yes.
Sorry, I was saying
Okay.
you're breaking up rather. Could you try putting off your camera?
Okay, which last word did you get?
Just go back to your previous
Hello?
sentence. I think we got most of it.
Yeah. Let me try to switch my connection. Hey, can you hear me?
Yes, yeah, I can hear you now.
Okay, so I'll keep going. Yeah, so how people perceive that cooking with electricity is, and this is because they don't know, they're not aware of this like the cost of cooking with electricity. Can you hear me?
Yes, you're coming through fine, thank you.
Okay. Do you mind telling me where I mean, what's the last sentence you got?
You were telling us that cooking diaries were very important. They gave very important data on different fuel uses and so on.
Yeah. So that's generally very good, giving this data to people and making them aware about the cost of cooking using different fuels. In terms of the questions, I think it will be interesting to understand, especially we know that if we want, for example, mini grid companies to work effectively, they need, to get this government collaboration. Just thinking around what kind of data set will be useful for the government. Are we collecting all this data for ourselves, or does the government also need this data? And if they need this data, what specifically data set do they need, and how will they be useful for them? So that's one point. And then also trying to think around how do we try to solve different issues, like the influence of political issues attacking maybe some mini grid companies. I know you have heard about this mini grid policy. I mean, the policy that the government of Tanzania gave to the mini grid companies to charge the electricity around the TANESCO rates. So do we see the future of mini grid companies in the countries where the policies are changed like this? And so how are we prepared to make sure that we have support to something like this? And then another thing as well, how do we make sure that all the customers are aware of the cost of cooking using different fuels? I remember we have this experience when we go to the field and try to explain to people that maybe cooking using electric pressure cooker is cheaper, and it's very hard to demonstrate that to people. And for example, people in the villages, their education level is not that high. what modeling structure can we put into our models to make sure that a layman can understand. Yeah.
Right, Ansila, it's Nigel here. You mentioned that when you're talking about political issues, and you mentioned the business of tariffs, and you said you guys know about it. Well, Matt and I know about it, but I think there's a lot of people on the call who wouldn't know about it. Would you be able to just spend a minute explaining a little bit more about what's happened with the policy on the tariffs for mini grids in Tanzania?
Yeah, so this is basically, so the Ministry of Energy and Water Utilities, so the Energy and Water Utilities Regulatory Authority gave an order to all mini grid companies to lower their tariffs, and they have to charge 100 per kilowatt hour and 100 Tanzania shillings, which is, I can say $0.001. So that's, and as we know, a mini grid is expensive to build and it needs a lot of resources. And so charging 100 Tanzanian shillings is not really going to work for mini grid companies. So as energy, as I can say, clean cooking sector, we are trying to make sure that we touch everywhere, like the mini grids, off grids and on grid settings, but it's kind of difficult if this kind of policies are happening around some countries. So it's a question to ask ourselves, how can we handle these things? It's a political issue, or is it something that is going to sustain for a long time? And if so, will the mini grid companies exist? And if they don't, so what next?
Thank you. Thanks.
Ansila, are you finished with your initial remarks? I wasn't sure because Nigel jumped in. Yeah, sure. Okay. Thank you very much. Excellent. Irene, could we invite you to make some initial comments?
I hope you can hear me.
Yes, you're very clear.
Okay, thank you very much. The first thing I could say is I would say is the thank you. We have actually been using the modeling, or rather the diaries, the cooking diaries. They've been very, very important for us as a company. I'll use those more because I'm yet to read the modeling that you're talking about. In fact, I'm really waiting for that report. I think it will be very useful for me and for the company as well. What you've done with the diaries was quite important for us because we, as a company, have come up actually with a policy from that, because from there we've realized that it's true. There are actually some equipment out there that are very, very energy efficient. And it's been a bit hard to convince the normal Kenyan that electricity, it's actually cheaper to cook with electricity. I'll give an example of a class I took yesterday to a demonstration center, which we call where we have some equipment, where the hardcore engineers who are not yet convinced. They were not yet convinced that it's cheaper. They were also not yet convinced that the meter that we're using, that you used, was actually the right meter. They thought the meter had maybe it was not okay, so we had to take the meter to our meter lab. Then we had it checked and whether it was calibrated properly, and it was. And we made a few things, and everybody now wants to buy from that class, wants to buy 2 or 3 of the EPCs. So we are already using that, the modeling that you used. And from that, we have actually come up with a policy that we want to have shops in starting off, maybe piloting with 3. We'll pilot off with 3 shops in banking halls, maybe in Nairobi, Mombasa, and Kisumu. We want to have shops where we're looking at energy efficient equipments where we can have them more put up in our banking halls, and then our customers can see and start buying. Majorly because we have more electricity than our demand is lower than what we have. So we want to sell more. We need to sell more. I think it was Besnik, the gentleman who talked before I did, who correctly said that we have brought in more customers, actually almost 4 million customers on board who are not taking up as much electricity as we hope they would. And these are customers that we want to actually start using things like the APC. And we are going to use a lot of these books to go out there and educate them. The first thing we need to do is education. So for us, financing is one of the things that we are going to be looking at quite seriously. How do we come up with a package that we can offer those people, especially the ones who've come on board, because they've come on board on 15,000, which is a loan. They just to get connected. They pay to get connected. They use 3 years. They pay through 3 years. So to get these EPCs, and the cost is a bit high. How do we do it? Are we going to give it? We were just discussing today. Are we going to make a policy where we can give a package, maybe an EPC, an iron, and a kettle or something? We first give them as a package as they get connected. What are we going to do? Because we need to do something as we do the education, so that they take up electricity and they understand that it's actually cheaper. Also, most of these people are farmers. And I think some of you are aware that we have the Shamba Shape Up program. So most of these people are farmers, and they're seeing through the Shamba Shape Up, quite a few of them are seeing that it is actually cheaper to cook with electricity. So if we take this, like the EPC to them, then they will take it up because they don't have the time or sometimes the energy to cook. And if they can have a shorter time to cook, then we know that it will be taken up. So we are very, very happy with the modeling that you're doing. The other thing for us, a question that we would want to pose to you is whether it's possible that every time you have something like this, the research, whether you can also take the meter numbers of these customers. For example, if it's in Kenya, this would help us know what was the usage before they took up the equipment. What was the usage in units, and how much units have they been able to add? Have they added even 1 unit to their usage? Or are they using just the normal, or have they even dropped? It would be important for us to know whether it adds value to have this energy saving equipment added to them. Does it add value for us to sell it, to sell the idea, to get on board? I don't know whether that's all I had. I'd written up some things, but I think most of it is that. Also, I think I'd mentioned, if it's possible, in the next one, I don't know whether you're going to do more. If you have anything for restaurants, small commercial, I think in Kenya and Tanzania as well, the small restaurants are basically always cooking lentils, beans. These are things that they're always cooking 2, 3 times or 4 times a day. So these are heavy users. Is there any future diary that is coming up for such people, schools and restaurants? Because they use, like schools, beans and maize. Those are things they use every single day. Is there any energy efficient equipment out there that can be used by these people so that they can also take up more electricity? Is there anything that Kenya Power, we can use as Kenya Power to form a policy on? Yeah, I think that's almost all I had.
That's excellent. Thank you very much. A rich set of options and ideas there. Thank you so much. So we had initial comments from all 3 of our panelists, some very some common areas, but some individual areas as well. I think we want to throw it open now to kind of questions or comments from the audience. Nigel, have you been watching what's come up in the chat? Do you want to kind of focus in on a few of those and invite people to put their points forwards?
Yeah, well, the first person that's put up a comment here was Martin, who was asking if there's been modeling on sort of scenario modeling at the regional or city level. And I'm not sure who'd be best to. Sorry, this was a question that came up not in response to the panel comments, but earlier, I think, in your work, Matt. Did you want to just speak to that about how the scenarios fit with the kind of urban, rural, city contexts?
I suppose all I would really say is that the costing report that's being launched on Monday, as we keep trailing, in a sense is very much case study based, and the case studies are of particular places, some urban, some rural. So in a sense, I think it's absolutely important that modelling and analysis is really well tied to empirical evidence, which means it often ends up being very place based. The challenge is how you then kind of stand back from that and draw some wider conclusions about and generalize those findings. And that's the kind of thing we've tried to do in that report. But there are only 5 case studies across, actually the whole world, because it's not even just Africa. It's got Myanmar in there as well. So that probably solves all of the requests. But it's a start anyway.
And there's another comment or request from Anne. And she has asked about how can model be used to develop attractive tariff pricing in a range of different scenarios. And I think that probably speaks back to the case studies in the cost perspective reports that we are endlessly mentioning during the course of this session. But Anne, if you're still online, can I pick on you and ask if you could respond to Irene's request for information on schools and what MECS program is doing regarding generating data from those schools and institutions. Would you be able to respond to her?
Yes, good morning, everybody. So
Hi, thanks, Anne.
We're very interested, Irene, regarding your question about institutions and schools. So MECS has a small portfolio looking at how we can introduce large energy efficient devices in schools, and we have managed to purchase an off-the-shelf EPC from China, 133 litre and 165 litre, which we'll be experimenting with, and hopefully we'd like to introduce that within schools in partnership with World Food Programme. They're fairly large with a 5 kilowatt capacity power rating, so it needs a bit of electrical work, but we're really interested in developing an e-cooking diary for schools and for larger institutions, universities, canteens, medical centres, hospitals, to see how they cook and what they cook, and if it's appropriate to use these type of energy efficient devices. And we'd love to have KPLC and the Energy Regulatory Authority in Kenya involved in this process. And we've been talking to John Leary about it as well. So really, really fascinating and interesting progress around this area.
Sorry, Irene, I should have introduced Anne because she's leading up our whole work stream in MECS, which is looking at opportunities for transitioning cooking in institutions in general. So there's a lot of work that she's managing there. Just looking at the comments that we got so far, they tend to be kind of on the detail of all the very interesting work that you've been doing, Matt. I think, can we ask people to kind of make the most of the really rich panel that we've got here, because we do have experts from a whole range of different sectors, private sector, mini grids, and the sort of the donor policy side. So if there's any questions arising for Besnik, Ansila, and Irene, I think that would be really good as well, because it's a real opportunity to have them with us just for another 20 minutes or so.
I mean, the other thing we could do while people are formulating their questions in response to that is we also wanted to ask our panel to comment on a kind of another topic area, if you like, which is really advising us how we can make our work more accessible to end users and practitioners and policymakers of different sorts. And maybe we've hinted at that a little bit in the discussion so far, but I just wonder whether we might just take this moment to ask each of them to just give us a very brief, if they've got any very particular thoughts on how to make things more relevant to their particular end use types, and then we'll come back to discussion and comments.
Okay, sure.
Should we just run through again? I mean, Besnik, any relatively quick thoughts on usability and how to improve that?
Yeah, sure. So yeah, like I think I mentioned earlier, some sort of toolkit would be very useful. So having some sort of planning tool that goes from like sort of the beginning of planning to execution, and what questions you need to answer to make that happen, right? So that could include kind of moving, I guess, more from the sort of the academic side to the more kind of breaking it down in simpler, more like user-friendly tools that you look at, you know exactly what you need to do. You may have to hire a consultant to do something, but at least you know the steps of what it takes to answer the questions in order to prepare an operation, right? And that could also include quantitative tools, like a model, for example, that you can kind of key in different variables, and the outputs change as you do that. So it kind of gives you a sense of where the sensitivities are and how the scenario planning might work out for people that are outside of the research, but it basically becomes kind of a friendly tool for them to explore. Yeah, I mean, I have other thoughts on kind of more longitudinal kind of research aspects of demand, but we'll park that maybe for another time.
Great, thank you. Ansila, any particular recommendations for us?
Oh yeah, I know. So I've been doing this cooking diary with Anna in some of their sites that you're operating here in Tanzania, and so it was in mini grid, and we decided to do a small pilot in on grid setting to see how things look like in the on grid, and it was quite challenging, especially in measuring the LPG. So I think maybe in the future we could try to find out something that will make that work simple, especially for cooks. Something like I know these technical people knows how to do it, but there are some sensors where you can put in the LPG and they'll show you whether when you use the LPG whether how much LPG has been used for cooking a certain food. That would be super useful. And I think another thing is, I have chatted this with some of you as well. We as ITA, we are developing this chat bot. It's a WhatsApp bot, which is trying to automate the cooking diary, and that pilot is still ongoing, and we haven't got full details yet, but those are something like which will make the process easier for people, especially avoiding hiring enumerators going in people's houses and looking if and entering the data. Yeah, so that's another comment from me.
Great, thank you. Finally, Irene, any thoughts on how to make material more accessible to KPLC or other practitioners?
Maybe a lot of people don't want to read too much, or maybe there are those who will want to read, and then there are those who just want to go to the end of the book. Like, for example, I've had to take the diary and write down, oh, the beans take this much. So is it possible to have this information as I seem to be agreeing with Besnik in a lot, like in a planned way, a simpler way, almost like a catalog, as have them in a way almost like an Excel sheet or a chart that shows this is this is the end, this is what the conclusion is. Not the comparison, so to speak, but with electricity, this is how much you're going to use for this. I don't know whether that makes sense. So makes it much more easier, such that if we were going to give it like to the Ministry of Energy, like yesterday I was asked for that by the Ministry of Energy, and if we got that, then it would be so easy. Then we just have it because it's something that is already there.
So Irene, is that what you've got in mind? I mean, I don't know if you've seen the e-cookbooks that have been drafted from the work in Kenya. I wonder if that's the kind of thing you've got in mind, or something different.
Yes, I have that. I have the e-cookbook. What I'm talking about is like a catalog almost at the end. I could see what was written. They had all the work that they did, but then you have to go into the individual and the comparisons now to get the details and break them down. So I was wondering whether it's possible for it to be now the electricity part only, the charcoal part only. So it's very easy to just at a glance get all the details out for those people who do not want to go into the nitty-gritties of what was done, of what every other person did.
Right, gotcha. So we need to, I think we need to come and get our Kenya research coordinator to come and talk to you about that in more detail, Irene, and make sure we can distill something that meets your needs. Thank you.
Thank you.
It's good to hear that we're at least asking the right questions, because we understand that there's a problem of communication. We don't necessarily have the answers on how to do it, but yeah.
Sorry, Matt, we've got a couple of questions coming up here for the panel. I think we might have covered this. What kind of key information is useful to the panel on a global level? This is a comment from Will Coley, who's clearly interested in the global market assessment that he and the Strathclyde team are working on as well. So he's pointed out that the global market assessment seeks to score countries on the viability of electric cooking in on-grid and off-grid locations. So he says, do the panel want tools and instruction manuals, reports, policy briefs? I think that's very much kind of speaking to the questions that you've all just answered. And I think the message we were hearing is that it's something simple. So I don't know if there's anything else to add on that, Besnik.
Well, but while Besnik unmutes, I would just jump in and say that Simon Batchelor has posted the one-liner infographic 1 pages, which I think is definitely a part of this need, isn't it? Or part of the solution, and it's something which the MECS program I know has got a strong focus on trying to bring things to simple messaging, but we don't always achieve it. Sorry, Besnik, over to you.
Yeah, thanks. I totally agree with Simon. I think that's spot on. I would say that so the global market assessment is very useful sort of to make the broader case, right? To with donors and development partners, even other governments that can see the potential at the global level to kind of create a sort of drive toward a new business line, if you will. But beyond that, I think then, when we get to the sort of country level, identify, right, that from that we can kind of skim the list and pick out several countries where we want to demonstrate some results, and then we can follow the protocols for the country level. So I think both are very useful and complementary, and so in that sense, the market assessment can be very useful to kind of see how things are changing at the global level. What is how many countries are basically showing a strong promise, and then going from there.
Right, I take my hat off to Besnik, who's agreeing with Simon that infographics are the way to go. I'm going to question whether you can get the complexity of the kind of modeling that the Strathclyde people have done on national grid networks, and whether an infographic is the appropriate format for that. Irene, could you just talk to the kind of information that your technical people would be looking for? And I think you said you've already engaged with them. What's the most effective way of communicating with these kind of guys?
The technical people, it's not hard. I think what you
That's encouraging.
what I saw, I was actually quite impressed that you went into the lines, LV lines, the cables, because that's questions that have been asked a lot. Irene, you're encouraging customers to use this. Are cables going to be able to handle it? Are the transformers going to be able to handle it? And the fact that you've gone into this, for me, I'm really looking forward to reading this and also having it so that they can also read it, because the technical people here will read it. So for me, that was quite encouraging, because there's some data now, there's some research done on that. And I think cables are more like Rwanda. I don't think they will have a problem there, apart from maybe the new areas, the new places where we knew that those customers are taking up very little. And of course, we put the very, very small transformers, but the cables will take it, and the transformers we can change as we go. So I don't expect that to be a problem. The infographic, I don't know, is that the word? I think that one is for the common person who wants to buy. Who wants to buy the items. That's what we need, or who wants information to be able to talk or teach. That is what we need. But for the technical, I think that's fine. The way you presented it, if we would want to see how it is. I don't think there'll be a problem there. They will read.
Okay, that's really interesting and very encouraging. Thank you, Irene. I think Stuart said just before he had to leave, I think he's probably teaching at Strathclyde University, that he'd love to for his team to get in touch with you. So we can maybe after the session invite them to just get in touch with you. Matt, how are we doing on time? We've got time for another.
We've only got about 5 minutes left, haven't we? And you and I wanted just a minute or two to give our kind of final reflections. Is there one more quick point, do you think, from the chat?
Just see.
Or should we begin to wrap up?
John Leary has just made a comment for Irene's benefit. We're working on a new set of data that categorizes the many different foods on the menu, so you can make easy comparisons between them. For example, in Kenya, heavy foods such as beans, matumbo, and mbuzi stew are all grouped together. There are also a lot of other food groups on the menu too. By grouping them together, we can create a much more comprehensive understanding of the compatibility of Kenyan cuisine with different appliances, such as the electric pressure cooker or induction stove. So that's we're continuing to squeeze more understanding out of the existing data that we've got. And the other thing to say is that this data, I think, is also being gathered by some of the other countries. I mean, we focused on East Africa with the contributions from Irene and Ansila, but I think you mentioned, Matt, before, there are MECS partners in South Asian countries and other countries across Africa generating this information as well.
Sure. Great. I think we probably should wrap up because people like to finish on time. I've got a few comments to make. Nigel, have you got anything you want to bring forward as kind of take-home messages?
I found, well, just what, I think all three panelists saying about the needing simplicity of message to get out to customers about that it's not actually that expensive, or not necessarily more expensive to cook with electricity, because that's a theme that's arisen. I mean, okay, we're only in the first week of these MECS events, and already that's a theme that's consistently arising, that there's this perception that cooking with electricity is too expensive. And so that's been reinforced today. And so the comments about some kind of simple method of enabling people like Ansila, Besnik, Irene to communicate with their constituents, with their customers, is really encouraging. Also, really interested that Irene's highlighted the role of these institutions, or the interest that KPLC have in institutional customers. And I think Anne will be encouraged by that and take that up. So those are, I think, my main takeaways, Matt.
Very good. No, I picked up on the communication to users and the institutional cooks. I think I'd add a couple of things. One is, I think Besnik in particular highlighted that actually there's a need for country level analysis and modelling and analysis. I guess my view is we often start at the country level because that's where the empirical evidence comes from, but it feels sometimes as though what we produce is then rather specific to that one place, and wouldn't it be great if we can just generalise? And I think there is an element of that, because you've got to be able to generalise to kind of convince the high level decision makers. But as Besnik is pointing out, I think you need that country level analysis also when you're trying to, for instance, work with the World Bank to support them making in-country investments. So actually that detailed country level work remains really, really important. And I think that for me is a good message to take away. And I also took away the message from a number of our panelists about the kind of needing a kind of a toolkit. I think that was Besnik's word, but it was supported by the others as well, that we need something that's kind of user friendly, that's got a step-by-step approach that kind of spells out the challenge areas and the steps towards addressing them. And it's kind of easier said than done, but we do aspire that the modelling we do should produce kind of open access tools which should be able to be taken up by others. I personally have not been great at achieving that because it's not very easy, but our Strathclyde colleagues, for example, on this network modelling have network tools which are or will shortly become available as open access tools. So KPLC could pick them up and use them themselves if they wanted to. So I think that's a really good aspiration to have. And I think we've also all taken the message that things like infographics and short forms for being able to inform about complex information is important. I think Nora put a message in the chat suggesting that pieces of work benefit from having different levels of detail of publishing about the complexity, but then the kind of simpler versions to appeal to different audiences, which is kind of obvious, but it's a really, really helpful reminder that we need to aspire for that.
Sorry, on that, Matt, I think Simon's posted a link to what looks like a video, which I suspect he's probably suggesting is yet another format that might work for communication. Simon, are you there? Do you want to just tell us briefly what you had in mind? Because it appears no one can open it. Sorry, this is a video which is still uploading. It's an unboxing of the big EPC for Irene. Okay, all right, I was wrong. It was just another interesting thing about it on the institutional side.
Yeah.
Now, I know that Simon, well, we've done a few kind of very small kind of short video, like sort of animations, almost like a kind of video infographic, just a few minutes, and they might be useful at some point for some audiences. Yeah. Anyway, sorry, Matt.
Well, I think we probably should wrap it up there and just thank everybody. I mean, I certainly found it very interesting. Really thank Irene, Ansila and Besnik for putting their ideas forwards, and thank everybody on the audience for the contributions that they made.